Okay, so let's wrap up radicals by talking about division in dealing with variables. So I'm going to try and get through this in a very straightforward way and not talk a lot. That way you guys can get some practice in. So let's go. So if I look at this first one here, I have the square root of 25/9. So one of the things you need to know that you can do with radicals is if it's over the top and the bottom of a fraction, you can separate it and make it on the top and the bottom. So the square root of 25 is 5, the square root of 9 is 3, ta-da! If it's already done for you, but you realize, wait a second, I've separated this, but 45 is divisible by 5, you're allowed to actually divide it. So 45 divided by 5 is 9, and the square root of 9 is 3. And then last but not least over here, 108 divided by 32. If I pull the calculator out here, that is not going to be perfectly divisible, but the calculator can simplify the fraction for me. So if I go into here and I do 108 divided by 32, and I math frac it, math, enter, mine decided to be mad. 108, my apologies, divided by 32. And then I math frac it. It will simplify it for me into 27/8. So this is 27/8. And then you can simplify each of those and say, hey, 27 is 9 times 3, and 8 is 4 times 2, which makes this 3 root 3 over 2 root 2, because the square root of 9 is 3, and the square root of 4 is 2. Okay? So we have 5/3, 3, and then this last guy over here, where you've got 3 root 3 and 2 root 2. So what did we really do here? We learned that you can separate the top and bottom into two radicals if needed. We learned that you can reduce a fraction inside a radical. And then basically you simplify after that. All right, so if you're dividing radicals, you can separate the square root or kind of put it together to reduce it. Now, here's the thing. With this last one, what we don't really like about this is I don't really like that there's a radical on the bottom. That often makes our lives a little difficult. So we do something called rationalizing the denominator to deal with that. So that's what we're going to do next. So if I come down here, when we simplify these, like this one looks like it's as simple as it gets, a 3 and a 5. Well, the problem is that's not simplest radical form. What we're going to do down here is what I just said. We are going to rationalize the denominator. Okay, so we are going to rationalize the denominator. And the way that we do that is we say, you know what? This radical needs another piece. So I am going to multiply by root 5 over root 5. Okay, well that seems a little crazy, but here's why I do that. On top, I just get 3 root 5. On the bottom, I get root 5 times root 5, which is root 25, which gives me 3 root 5 over an actual 5. Okay, 3 root 5 over an actual 5. The reason that's called rationalizing the denominator is, if you can remember this vocab word, root 5 is an irrational number. It's a big, ugly decimal. But when I multiply root 5 times itself, I get regular 5, which is a rational number. So I have rationalized the denominator. Good, yay, good for me. So that's it. So if I come over here to root 40 over root 15, the first thing I'm going to do is reduce this and say, well, 40 over 15, 5 goes into 40 8 times, 5 goes into 15 3 times. So this is the same as 8/3, or root 8 over root 3. Okay, again, 40 15ths. I just said, hey, 40 15ths, math fract is 8/3. And then I realize, wait, there's a radical on the bottom, and that's not allowed to stay there. It's just an ugly way to leave things. So I am going to rationalize again. How do we rationalize? Well, there's two radicals here, but the only one that bothers me is this guy on the bottom. I don't like radicals on the bottom. So when that happens, you multiply by the radical you want to get rid of. So down here in the box, I want you to write again, rationalize the denominator. Oops, I spelled denominator wrong. Denominator. Rationalize the denominator by multiplying the top and bottom by the radical you want to get rid of. Okay, so over here, I was trying to get rid of a root 5, so I multiplied by root 5. And over here, I'm trying to get rid of a root 3, so I multiply by root 3. Now, what happens when I do that? Root 8 times root 3, when you multiply radicals, you multiply the inside, so I get root 24. Root 3 times root 3 is root 9. The square root of 9 is 3. And 24 actually breaks down into 4 times 6, which makes this 2 radical 6 over 3. Okie dokie. And then last but not least, root 3 over root 2. The root 2 is the one that's bothering me, so I'm going to multiply it. Root 3 times root 3 is root 6. Root 2 times root 2 is root 4, which gives me root 6 over 2. Ta-da! All right, how am I doing on time here? 7 minutes, not too bad. So let's turn the page. Why do we bother rationalizing denominators? I just want to give you guys a reason for what we're doing instead of me just rambling on here. If I asked you between which two whole numbers does this lie, that's actually a pretty easy answer to get, because the square root of 15 is like close to 4, but slightly under 4. And then I'm dividing by 3. So this is like approximately 1 1/3-ish. So it's between 1 and 2. If I said, what's this in between, which, believe it or not, is equivalent to that, I don't know, because I don't know what the square root of 5 is as a decimal, nor do I know the square root of 3 is a decimal, so it's a little bit harder to tell. Okay, so this, which is in rationalized form, is happy. This, not so much. Okay, and if I come down here to 5 over root 7, I keep telling you that's not okay. There's technically nothing wrong with it. It is a number. It's just that mathematicians don't tend to leave it that way. So what we will do is rationalize it, just like we just talked about. Multiply by the radical I want to get rid of. So now I have 5 root 7 over root 49, which is 5 root 7 over 7. And then my question was, which looks better to you? Well, honestly, I kind of think that first one looks better because I just have 1 5 and 1 7, and now I've got 2 7s and a 5, and that's just annoying. Okay, now, again, the point is we are still supposed to do this, but I want you to understand that technically there's nothing wrong with the first one. It's just often easier to deal with when it's in rationalized form. Okay, last but not least here, I want to talk about dealing with variables, and then I am done, and you guys can do some practice. So here's the thing. Remember that get out of jail game that we talked about yesterday? That's really helpful when we deal with radicals and variables. So if I have the square root of x to the 6th, what that means is there are 6 x's all being multiplied together in jail, and they want to escape. So what do? They buddy up. So all 6 of these x's are in jail. These guys make a plan, dig through the jail, pop out on the other side, but this guy gets caught. These two make a plan. They dig to the outside. This guy gets caught. These guys make a plan, dig to the outside. This guy gets caught. So I have 3 x's outside of jail and nobody left in jail, x times x times x is x cubed. What's really going to happen there is anytime you have an even exponent, anytime you have an even number of similar convicts in jail, they partner up. So when square rooting an even exponent, just cut it in half. Have it. So like the square root of x to the 12th is just going to be x to the 6th. Because of those 12 inmates, they make 6 total pairs. 6 guys escape, 6 other guys get caught and sent to another prison. Okay? So if you have an even exponent, you have it. Well, what if I have like an exponent and a coefficient? I just separate them. So I've got the square root of 20 and the square root of x to the 15th. So 20 is 4 times 5. So this is 2 root 5. And x to the 15th, okay, whoa, that's a lot. That's 15 x's. I don't want to be circling 15 x's. So what we're going to do is try to get back to here. If I have an even exponent, I know I can cut it in half. Well, x to the 15th is the same as x to the 14th times x, right? X to the 14th times x would be x to the 15th. And x to the 14th is even, so I can cut that guy in half. And this x is all alone, it can't go anywhere. So a 2 and an x to the 7th are outside the radical, and a 5 and an x are inside the radical. Okay, so we're going to also write in here, we are going to write do coefficients and variables separately. What I mean by do is really simplify the coefficients and the variables separately. Cool. Let's try it one more time then. So we're looking for even exponents, and we're going to do the coefficients at a different time. So on this one, I have a 6 outside, I have a 12, I have an x to the 12th, I have a y to the 7th, and I have a z to the 3rd. All right, so the square root of 12, 12 is 4 times 3. X to the 12th, 12 is even, just gets cut in half. And these are both odd, so y to the 7th I'm going to write as y to the 6th times y, and z squared times z. Okay, 6 plus 1 is 7, 2 plus 1 is 3. Okay, wow, there's a lot of stuff going on, but I'm only going to think of a piece at a time. So the square root of 4 is 2. 6 times 2 is 12. So that's 12 radical 3. I have an x to the 6th here. Y to the 6th gets cut in half. And z squared gets cut in half. And then when you have all these pieces, you just take anybody who doesn't have a radical and put them all outside. And anybody who does have a radical and bring them inside. So my final answer here is 12x to the 6th y cubed z times the square root of 3yz. It looks overwhelming, but just take it a step at a time. Okay? So, really quick, let me do these guys down here, and then you guys are done listening to me drone on from behind a screen. So if I have this, I have a fraction with two things. I can't simplify it yet, so I'm going to separate it and say that's root 4 over root x to the 4th. The square root of 4 is 2. The square root of x to the 4th, that's even. It gets cut in half. Done. The square root of 32x, I'm going to separate it. Square root of x I can't do anything with. And 32 is 16 times 2. So the square root of 16 is 4, and 2 and x are both in a radical, so they both get multiplied in a radical. Last but not least, here's another fraction, so I'm going to separate it. And then when I separate it, I realize, wait a minute, the square root of 3x, I can't break it up or anything, but I'm also not allowed to have it on the bottom, so I'm going to multiply by root 3x. So 1 times 3x is 3x. 3x times 3x is 9x squared. So I still have this root 3x on top, but the square root of 9 is 3, and x squared is even, so I cut it in half, x to the first. And that's your final answer. Okay, so I am done. I always tell you a stupid joke at the end. So my stupid joke today is, why was 6 afraid of 7? Because 7 ate 9. But why did 7 eat 9? Because 7 knew he needed 3 square meals a day. Get it? 3 square? 9? Oh, funny, funny, funny. All right, I'm done. I will see you guys all soon.